today, we will take some examples where arithmetic sequence in series is applied. So let's take this one. We are asked to find the sum of the first 10 integers that are multiples of 5. So in my thinking, I know that the first integer that is a multiple of 5 is 5. It is followed by 10, 15, 20, 25, 30, 35, 40, 45, and 50. So that makes the sequence of 10 terms whose terms are all multiples of 5. So how do we do that? One specific idea where we can apply is this one. So if you take a look at this, there is a pairing of 5 and 50. So meaning that the sum of these two is 55. Same with this one. 45 and 10 gives us 55. 15 and 40. 20 and 35. 25 and 30. As you can see, these are all, the pairing all have the sum of 55. So meaning, if I have 55 as one sum of a pair, but in my thinking, how many pairs of 55 are there? So we have 1, 2, 3, 4, 5. Which means that since there are 10 terms, there are 5 pairs of numbers whose sum is 55. Therefore, the sum of the first 10 terms is 55 that is multiplied by 5 pairs. In that case, I have 275. Another way of answering this is through using the equation S sub n is equal to n times the quantity of a sub 1 plus a sub n all over 2. So how many terms again do we have from 5 to 50? How many terms are there? Yes, that's 10. So meaning that our n is 10. How about our first term? The first term is 5. The last term, which is the 10th term, is 50. So using this equation, we have now S sub 10 is equal to 10 times 5 plus 50 all over 2. Again, the sum of the first 10 terms of this sequence is 10 times the quantity of 5 plus 50 all over 2. So, simplifying this, we have now 55 all over 2. But since 55 is not divisible by 2, but 10 is, so 10 divided by 2 is 5, times 55 is again equal to 275. Therefore, the sum of the first 10 multiples of 5 is 275. So how about this example? We are asked to find the sum of the first 12 terms of the arithmetic sequence whose first term is 6 and the common difference of 8. The first thing that we need to do is to identify the given. What are the given? So we have the first 12 terms, so meaning our n is 12. The arithmetic sequence of whose first term is 6. So this is our a sub 1. And the common difference is 8. So this is our D. So we have two actually options as to how are we going to solve this. Here's the first one, wherein um, the only the only terms that are involved are the first term and the last term or the 12th term, right? And the number of terms. However, on this side, we have the sum of terms, which is equal to n over 2, again, n represents the number of terms, a sub 1 represents the first term, and the d is the common difference. So, which of these two equations is the most um, comfortable to use? So, tingnan natin yung mga given. So, we have n, a sub 1, and b. And in here, all of them are involved. So, what do? We have to substitute. So, we have s sub 12, because we're talking of the 12 terms, is 12 over 2 times twice the first term. What is our first term? 6. And then we have 12 minus 1 multiplied by the common difference, 8. Okay, simplifying this now, we have 6 multiplied by 12 plus, what is 12 minus 1? That's 11 times 8. So, simplifying first, the ones that are inside the grouping symbol, or grouping symbols, we have 12 plus 88. And what is 12 added with 88? That gives us 100 times 6, so that would be 600. Therefore, the sum of the first 12 terms of an arithmetic sequence whose first term is 6 and the common difference is 8. How about this one? Can we use this one as well? So, the first thing that we need to do is to find the 12th term. So, how do we get the 12th term? A sub 12 is equal to a sub 1 plus n minus 1 times d. Okay? But the d here is 8. What again is our n? Our n is 12. What is our first term? The first term is 6. Okay. So we have now 6 plus 11 times 8, which happens to be our 12th term. Okay? So 11 times 8 is 88, plus 6 is 94. Now, using this equation now, we have now the sum of the first 12 terms is equal to the number of terms, which is 12, times the sum of a sub 1 added with the 12th term, which happens to be 94, all over 2. So in this case, we have 6 plus 94, which again is equal to 100, divided by 2 is 50 times 12, or we could have this one divided. So that now would be 6. 6 times 100 is again 600. Therefore, whatever equation you are going to use, you will arrive at the same answer.